Hello everyone, in this module I am going to teach you Hantzsch synthesis. A general method for the construction of pyridine ring is the Hantzsch synthesis. That is, in this method we are going to synthesize pyridine ring as well as its pyridine derivatives. The reaction allows preparation of dihydropyridine derivative. This is dihydropyridine derivative. This dihydropyridine derivative can be synthesized by the use of 1 equivalent of aldehyde, 2 equivalent of beta keto ester along with ammonia gives this dihydropyridine derivative, which on oxidation or the removal of this dihydro groups leads to the formation of this 3,5-dicarboxylate pyridine derivative, that is aromatization of this dihydropyridine derivative will takes place here, which on decarboxylation or which may undergo decarboxylation to yield substituted pyridine derivative. This is all about Hantzsch synthesis. This is reaction of Hantzsch synthesis. Now, let us understand this reaction by its mechanism. In the first step, we have used 1 equivalent of beta keto ester along with ammonia. Now, this lone pair of electrons on the ammonia will try to attack more electron deficient carbon center. Here 2 carbonyl carbons are present, one of ester and one of ketone. Okay. So, to determine which one is a more electrophilic in nature, here is a alpha effect involved. Alpha effect, that is heteroatom connected, which heteroatom is with lone pair of electron. If it is present at the alpha position of carbonyl carbon, then it is called alpha effect. The generated positive charge can be stabilized by the lone pair of electron present on the alpha heteroatom, which makes this carbonyl carbon less electron deficient. Hence, this ester carbonyl carbon is less electron deficient as compared to this ketone carbonyl carbon, just because here is the absence of any heteroatom which having lone pair of electron, which will show alpha effect. Hence, attack of this lone pair of electron of nitrogen at the carbonyl carbon leads to the formation of this molecule, which involves internal proton transfer from this nitrogen towards this ketone oxygen, leads to the formation of this hydroxy group. This hydroxy group can be cleaved in the form of water molecule by abstracting alpha proton, leads to the formation of this alpha beta unsaturated carbonyl compound, which can also be termed as alpha beta unsaturated beta amine ester. This is a first step and this product is a termed as A product. Okay. In the second step, another molecule of beta keto ester is used. This beta keto ester generally is in the form of keto form, which can also be converted into enol form. Enol form, that is carbon double bond having alcohol, that is enol form. Okay. Now, in the enol form, this carbon-carbon double bond is behaving as a nucleophile in nature that can attack at the electron deficient carbonyl carbon of the aldehyde by sharing its or by donating its pi electron pair toward the carbonyl carbon, leads to the formation of the here carbon carbon bond formation. Now this oxyanion by the attack of the pi bond at the carbonyl carbon generated here can be stabilized by abstracting proton from this alcohol of enol, and again generation of here keto form at the beta position. Then hydroxy group generated here can abstract alpha proton from this alpha carbon, hence involve a removal of water molecule and leads to the formation of alpha beta unsaturated beta keto ester. In both the step, here is a removal of alpha proton will takes place. This product form here is shown by B. In the third step, compound A, which have been generated, which have been synthesized in step 1, combines with undergo condensation with product B of second step. Here lone pair of electrons on the nitrogen will share or donated to this carbon, to this carbonyl carbon, sorry, this pi bonded carbon, which involves carbon carbon bond formation with this alpha beta unsaturated beta keto ester. Hence when carbon carbon bond form here, here is a formation of carbon carbon bond will takes place. Okay, here is a carbon nitrogen double bond. It will create formation of negative charge at this alpha carbon. Okay, at this alpha carbon. Now this alpha carbanion will abstract proton from the alcohol, which is used as a solvent in the reaction medium. Okay, this alpha carbanion will abstract proton from the alcohol and stabilize this carbanion, stabilize this carbanion. Okay. Now here is a positive charge generated on the nitrogen, which is electrophilic in nature, bearing a positive charge, which is not good. So to stabilize this positive charge or to neutralize itself, nitrogen will pull pi electron pair toward itself, pi electron pairs toward itself. Hence getting back its lone pair of electrons, but creating electron deficient carbon atom at its adjacent position, which can be stabilized again by the removal of alpha proton from the left side, of ester moiety, which will leads to the formation of which will leads to the generation of carbon carbon bond formation, that is again alpha beta unsaturation will takes place here. Okay. Now in this fourth step, lone pair of electrons which getting back by the nitrogen will attack at the now this lone pair of electron on the nitrogen will attack at the carbonyl carbon, leads to the formation of carbon nitrogen bond, and positive charge generated at the nitrogen will be stabilized by the abstraction of proton by this oxyanion. Then again removal of this hydroxy group by the abstraction of alpha proton will leads to the generation of dihydropyridine derivative. Now this dihydropyridine derivative undergo oxidation, that is removal of two protons, that is one proton from this one position of nitrogen and another proton from this fourth position will takes place, leads to the formation of this 3,5-dicarboxylate pyridine derivative, which then again undergo decarboxylation to generate a desired product, which is substituted pyridine derivative. Okay, this is the mechanism of Hantzsch synthesis. Now these are applications of Hantzsch synthesis. It involves use of two equivalents of ethyl acetate along with formaldehyde and ammonia, which leads to the formation of 2,6-dimethyl-pyridine derivative. Again in the second application we have used here ethyl acetoacetate, 2 moles of 2 equivalents of ethyl acetoacetate along with 2-chlorobenzaldehyde and ammonia, leads to the formation of this substituted pyridine derivative. Again here it is a mechanism of this second application. Here in the initial step, nucleophilic attack of lone pair of electron on the nitrogen leads to the formation of this product A, that is alpha beta unsaturated carbonyl compound. In the second step, another mole of beta ketoester undergo ketoenol tautomerism, leads to the attack of this pi bond which have been generated here, that is alpha beta unsaturation scheme will attack at the carbonyl carbon, leads to the generation of carbon carbon bond formation along with the removal of water molecule, leads to the formation of this alpha beta unsaturated beta ketoester molecule, which is a B product. Here B and A combines to give this product, which on nucleophilic attack of lone pair of electron at the carbonyl carbon and again removal of water molecule leads to the formation of this dihydropyridine derivative, which on oxidation followed by decarboxylation gives desired substituted pyridine derivative. This is all about Hantzsch synthesis. Thank you.